Now, section 5 looks at graphs of sines and cosines. When we get to 6, that deals with all the others. Okay? Sines and cosine, though, they focus on this for you when you're dealing with all the different types of transformations that come up. Now, things about sine and cosine is the fact that they repeat. So you never have to actually graph the whole thing because it goes left and right forever. But you need to show a minimum of one cycle unless it asks for more. Okay? One cycle of these, that's just the period of the function. Now, typically, if you just think in terms of unit circle, you're going around the outside of the unit circle from 0 to 2 pi. That's one cycle. And that's what this thing does. It takes your angle value over here and compares it to, since this one's sine, it compares it to the y value on the unit circle. Okay, so the x-axis becomes all your angles. So at 0, you have 0 for the sine, pi over 2 is 1, pi is 0 again, 3 pi over 2 is negative 1, and 2 pi is 0 again. So, sine starts where that hits at the origin, and it's an odd function. Now, when I take a look at cosine, the only difference is cosine starts at 1, and then goes down and keeps that same cycle going. Okay? So, putting them both next to each other, you can see that you have 5 main points that come up. And this is what I want you to, when you're doing a rough sketch, this is what I want you to graph. Your max points, your midpoints, your intercepts, and then just kind of draw that rolling curve between them. Okay? It does not have to be perfect. But you're going to have to be able to generate these, and you're going to have to be able to move them around a little bit. Okay? So if I take the default cosine function, and I put a 3 in front of it, what's that 3 going to do to the graph? It's going to vertically stretch it. A 3 out front's being multiplied by the whole function. It's going to vertically stretch it. So that, because we're talking about a sine wave, and the cosine wave, whatever, what do we call that change? Or what do we call that 3? What's that going to be? Anybody remember the word for it? The amplitude. The amplitude of the function is going to match this. And that's what that means is that's how far off the midline you are. Okay? So I'm going to go up and down 3. Now I'm not shifting at all because I'm not adding or subtracting anything from this. So it's going to behave just like cosine, except for instead of going up to 1 and down to negative 1, it goes up to 3 and down to negative 3. Okay? So the nice thing about cosine, where does it start at? Does it start at the origin or does it start at 3? Start at negative 3. At 3. When's it going to get back up to 3? After the end of the period. In this case, that would be 2 pi. So I'm just going to mark out here 2 pi. Now it does ask me to go to 9 pi over 2 and to start at negative pi over 2. So if that's 2 pi, 1 pi is going to be here. If that's 2 pi, 4 pi will be here. And there's 3 pi. Where's 9 pi over 2 going to be at? Yeah, the idea is if I keep this going, 5 would be about here, so then 9 pi over 2 is going to be here. And then I'm just going to put all the halfway marks as well. I also need to go left to negative pi over 2, so that's going to be about here. Okay? I'm still just going to put in those 5 key numbers. If your max here, we said the max occurs again at 2 pi. Where's the minimum going to be? At pi, negative 3. Yep. Where's the intercepts going to be? Halfway between each of those. Yep. And then I would actually just continue this pattern. The 2 pi, the 0 pi, and the 4 pi will all be maxes. The pi, the 3 pi, and if I kept going, the 5 pi would all be mins. And then all the anything over 2 is going to be an x-intercept. And then just draw your curve. Try not to make V's out of it. Just kind of have it be a rolling curve. Think roller coaster. And try not to murder anyone on the roller coaster. Okay, so if it says graph from there to there, you do need to make sure you graph the whole thing. If they just say general sketch, honestly, I would just probably graph that. One full cycle. Questions? Okay. From there, that's the amplitude shift. You can also have a shift in the period. So instead of being 0 to 2 pi, it might be 0 to pi or 0 to 4 pi or something along those lines. Okay. That front number, though, they will always do absolute value of a for that. The one thing you got to watch out for is if it's a negative. Now, a negative sign is going to flip it over the x-axis. So instead of cosine starting high, it's going to start low. If sine was made negative in front, it'd still start at 0, but instead of going up, it'd go down immediately. Okay? So, the amplitude change is just that absolute value of A out front. The period change, now this book does a little bit differently than FS&T book does it. I think it's about the same as what you did in Plus, though. This A value is going to give you your amplitude. This B value you can use to find the period of the function. All you do is take one full cycle, the default, divided by whatever that B value is. B being the number you're multiplying the x by. So you just take 2 pi over B. So when you go to these problems, the first thing I do is actually just write down what A and B are. Okay? So on this problem, what would A be? 1. What would B be? 1/2. Okay? Then the amplitude is just that 1, whatever A is the absolute value of it. And then period, though, is going to be what? 2 pi divided by 1/2, which is going to simplify out to be 4 pi. Now, since the instructions here are just saying to sketch the graph, I'm just going to do one cycle of it. So the graph ends up looking almost the same every time. Just instead of going 2 pi, I'm literally just going to label this 4 pi. Okay, then halfway between, and then split those into fourths. That way you have your 5 main points. Now it is cosine, so where's this thing going to start? At 1. So I'm going to start up at 1. It's going to hit as it crosses through, and then hit bottom out at 2 pi. It's going to hit a 0 again at 3 pi, and then top off at 4. And then just draw your curve. Okay? So the section pretty much comes down to. Now, when they start adding numbers in between, that's where it can get a little bit more complex. Now, this I do a little bit differently than the book. I draw the number from the same spot. And they actually end up calling this a phase shift of the graph. Okay? And the reason is because if I just had an x here and added 2 pi, it's going to move the whole thing left 2 pi. But think about it for a second. If you move sine left 2 pi, what's going to happen? It's the same thing. That's why it's called a phase shift, because you can just shift them a little bit and get back to the same result. So what you're going to do for this is actually use both the B and the C value. Okay. Now what they do here is they actually, in the book, I don't usually go through it this way, but it will talk about it. One full cycle runs from when this thing starts at 0 to when it ends up at 2 pi. So what you can do with that is actually solve those for the x. The idea being, if you go from C over B on the left, you would stop at C over B plus 1 cycle on the right. That to me is a little bit confusing, so what I do instead is I just look at this C over B value, and then that's how far you're going to shift the graph. Take every single point on that graph, those 5 key points, and move them over by whatever C over B is. Okay? So, now we add another number to the mix. You have that amplitude is A, period is 2b or 2 pi over b, and they actually say 1 cycle is this. The way I just say it, your phase shift is just C over B. Okay? So looking at this next function, what's your A? B. 1, it's just the number in front of x. C is pi over 2. C is the number that you're subtracting from x. See here, up here we have A, your B, and your C. Now I'm going to use those three things to find the amplitude, the period, and the phase shift. So amplitude is just going to be whatever the absolute value of A is. So that's just 2 still. The period would be what? 2 pi. Because it's 2 pi over 1, it's just going to be 2 pi. And for the phase shift, that's just C over B, so that's just going to be what? Pi over 2. Pi over 2 divided by 1 is still pi over 2. So, from there, generate the graph. The period's still going to 2 pi, so that'll be enough to show a cycle. but it's going to move a little bit. So I'm just going to start with that there. And my think of my 5 key points. Okay? Now the amplitude is 2, so I need to go up to 2, down to negative 2. Where would this thing start if the phase shift wasn't here? 0. So the idea is we'd have zeros at 0, pi, and 2 pi, and then peak in a valley between. But this pi over 2 is going to do what to all those points? Move them to the right, pi over 2. So the zeros now are here, and I'm going to extend this a little bit to have it here. The peak is going to be where? At pi, it's going to be all the way up at 2. And the trough? At the 2 pi. So your curve just moved over pi over 2. If you graphed a little more than that, I wouldn't penalize you or anything. Just make sure I'm seeing at least one cycle with all those points. Questions so far? Yeah?
Would you put arrows on those graphs or just leave them like that? Or would it matter?
It wouldn't matter. It's a rough sketch. I'm assuming you got the idea that it keeps going left and right. The book might or may not put arrows. If it's going from, like the one that went negative pi over 2 to 9 pi over 2, if you had arrows there, I wouldn't even penalize you for it.
But like on the test and stuff, it doesn't matter?
Yeah.
All right.
Yeah.
When like labeling points, is that like with those numbers they're sufficient, or do you want like?
That's no, that's there sufficient. Yeah. If you want to do more, I'm not gonna dig you for it. Okay, let's do another one of those. What do I look for first?
Three things.
3 things: A, B, and C. What's A? A is actually still negative 1/2. When I go to amplitude, that's when it goes absolute value. So I want to keep that negative in mind because it's going to affect the graph. What about B?
Negative.
Pi. C? That one will be negative pi. Okay, because the default formula
That's
is A trig function bx minus c. Whichever one you're adding or subtracting in here, you're going to do the opposite of what you see. Okay. So then amplitude, that's going to be 1/2. Yep. Period. 2, because you have 2 pi divided by pi, will just be equal to 2. Phase shift, negative 1, because you have negative pi divided by pi is going to simplify out to negative 1. So when I'm going to graph this, is going to be a little bit different because I'm not going to have pi anywhere along the x-axis, but it works the same way. I'm still going to go out to whatever the period is. So I have 2 out here, halfway is 1, and then each of the halves. Now, this is sine though, right? So where would it, ignoring the phase shift, where would it start? 0. And then it would hit again at 1 and then again at 2 for sine. It's only going to go how far up and down? Half. So if 1's here, it's going to go up and down to half. And which way will it go at the start? It'll be going down first because of the negative 1/2 here. It's going to come down and come back up through 1. Okay? So from there, the only thing left is what? To shift it. So instead of actually having the zeros, well actually, the zeros are just going to stay what? The same. Okay, this thing's shifting left 1 unit. So I'm going to go over to here. These 3 points are now my 1 cycle. From here it's going to start, it's going to go down, it's going to hit a low point halfway between, come back up through the origin, hit its high point, come back down to 1. There would be your 1 cycle. If I kept going with it, it would just end up there, right? Well, if you look at this, these 2 things actually negate each other. And you'll see this kind of thing happen a lot. If I just started here and went, well, the fact that it's negative 1/2, that would actually allow me to completely just throw out this pi. This function, if you graph both this one and 1/2 sine of pi x, you would get the same graph. That happens a lot. So there's a lot of different versions of these things that'll come out to be the same graph. And it kind of takes playing around with them to get comfortable with how the shifting affects that. Okay, so far we've dealt with stretching it vertically, that's amplitude change. Stretching it horizontally or shrinking horizontally is a what change? Period. Phase shift is a horizontal change. What's left? Vertical shift. Because you can't have vertical shifts as well. This one actually has a vertical shift. Why?
Because the negative minus 5 is not.
There's no parentheses. -5 is outside of the function. Since there's no parentheses, it's implied that the x is the only thing inside the function. So I actually now have a fourth letter. A, B, C, and D. A is what?
2,
B?
1,
C.
0.
0. There's nothing inside with the x being added. Outside of it, I do have what? -5. Because it's a vertical, it keeps the sign. The horizontal ones are the ones that behave in the opposite manner. Okay? The vertical changes, the 2 and the 5, because they're outside, the -5, affected exactly how they read. So, from there, the amplitude is what? 2. The period?
2 pi.
2 pi, yep. Phase shift. 0. C is 0, so it doesn't matter what B is. And the vertical shift. -5. It's just going to be whatever that number is. Because that number is going to move every single value down 5. So when I go to graph this, well, I know I'm going to have to move that thing down -5, but since I'm moving every point, I actually just think of what the midline is. On a default cosine function, what's your midline? 0. It's y equals 0. It's the x-axis, right? So if I just move everything down 5, that new midline is going to be where? Y equals -5. So I'm going to graph this a little bit differently. I'm going to start up here. And this thing has an amplitude of what? 2. So normally it would be going up to there, its max. But because of the -5, I'm going to move down to -5 here. And I'm also going to do a couple more because of that amplitude. I need to go at least 2 past that. Okay? Or I need to go 2 past that. So then this is cosine. So where would it start?
Negative.
At -3. Okay? Now I'm also going to put these marks out here. The period's the normal 2 pi, so I'm just going to put those in. And then if it helps, kind of do just a real light line at that midline if it helps you graph it. So then 2 pi, well, where's it going to be when it gets around to 2 pi? Since this is cosine.
I'll put -3.
-3, yep. So it's going to be about there. Where's the trough going to be? Pi and how deep? -7. Okay, and then at pi over 2, and at 3 pi over 2, it's going to be at those midlines, that midline. There's no phase shift at all, so this thing doesn't move left or right. So then I'm just going to rough sketch. Questions so far? Okay, now you do get some that are a little more abstract and require a little bit more thought. For this one, normal monthly temperature in degrees Fahrenheit for Albany, New York for 6 months are given on the table. Use a trig function to model this data. This you got to get a little bit creative with, because the thing is, what trig function would you use for this? We'll stop and think about which one makes sense. I'm starting with January. If I were to graph this, January starts out at 21 degrees, right? November ends up at 40 degrees. In between, this thing rises, and then drops back down. Well, which trig function does that look like? Sine or cosine? It's going to be one of those two. Which one's going to be easier? Why cosine?
Inverse. Like minus.
And negative cosine, because it starts low and ends low, right? So the easiest thing to work with for this is going to be cosine, but it's going to be negative because I want to start low, not start high. If you're starting in the middle and end up going through some type of cycle and end up back in the middle, that's when you use sine. If you're starting with something low or high, I use cosine. Okay? Now the book might do it with sine sometimes and then adjust with a phase shift. Because you can actually get from sine to cosine with a phase shift as well. This to me ends up writing much, much quicker. Because if I have cosine there, now I can also figure out, you kind of want to work backwards a little bit. Figure out what your base function is. Then I want to work with the last piece first. What would the vertical shift be on this? Because the thing is, I want the midline to be halfway between your peak and your valley. Well, where's the lowest value you have up here? What's the highest? 72. Assuming that's your highest and lowest, where would the middle be? Between the two of them, what would it be? 46.5. Subtract these two things and divide by 2. Okay, then take whatever you get and add it to the 21. Okay? Actually, you could add them both and divide by 2 as well. That would work as well. Anyway, you get 46.5 is where this middle is. What does that tell you? Yeah, you shift up from 0 at the default up to 46.5. So that value is just literally D. D equals 46.5. Okay? I try to avoid a phase shift if at all possible, just because that's the thing that usually makes them look the most complicated. So the next thing would be, well, the other easy one to figure out. What's the amplitude?
25.
Say again?
25.
How'd you get it?
Subtract 46.5 minus 21.
Yeah, just the distance down will be the same as the distance up. So the amplitude, or the A value, will be 25.5. Now I do need to remember to make it negative because of the fact that it starts low. What's the only thing left? Assuming I'm not going to mess with phase shift. Period. What would the period of this thing be? I'm just asking what the overall period is. Why would it be 12? 12 months. Right? The period is 12. Now that 12 would have to be equal to 2 pi over b, which allows you to solve for b. Okay? If I solve this for b, cross multiply and divide, you get pi over 6. You have 12 pi, or 12 over 2 pi. Wait. Sorry. 2 pi over 12. I'm awake. Which simplifies down to pi over 6. So that's your b value, your a value, and your d value. This thing isn't going to have a phase shift because I'm starting it at its trough. Starting it as low as possible. So I can just write the equation. Y equals 25.5 times cosine. What? Negative, not inverse. Negative 25.5 cosine. What's going to be inside the parentheses?
Pi over 6x.
Pi over 6x. Your b value is pi over 6 times x. I have nothing else added inside there because I kept the phase shift neutral. What else? Plus 46.5. That's your trig function that models this data roughly. Does that make sense? Okay. What would your... Nah, don't worry. Then they'll ask you some questions about it. Like, how would you figure out the normal temperature in December then? Plug in 12, figure out what you get. Yeah, plug in 12 for x and simplify. What would you want to make your calculator be in? Radians, because of the pi over 6. And questions like that. Any questions on any of it? Okay. The rest of the time is yours. Make use of